All right.
All right. So, I mean, Damo, the big thing last week, that'll be kind of to your point exactly, really, about the isn't there like some kind of function like reduce or something that you can use to, instead of doing this recursive business like we're doing here for product, we could just we could iterate over the list and kind of accumulate the result. And it turns out there is these handy little functions up here called, where are they? foldRight and foldLeft. And foldRight and foldLeft, they're kind of like the tools you use to when you want to perform something over a list. So like basically most of the functions for the standard lib for a list can be implemented in terms of foldRight and foldLeft. And the key idea,
they kind of concat inside of reduce or something, do they?
They're kind of like I mean, it's very. I guess the best way to put it is that just kind of recapping what we did last week was if this is a list 1, 2, right? 1 cons with 2 cons with nil. So that's how you would write. That's how you would write a list. Well, if we take that, you could kind of think, well, it would be kind of convenient if I could replace cons, right, this function here, with some binary function, and I could replace nil with some default value, some other value. So if I did this kind of swap, right, and they call this constructor replacement, I could, in the terms of product, I could make something that looks like a product by just replacing cons and nil. So I could say, well, if I could replace cons with multiplication, and I could replace nil with 1, then I would have implemented, taking the product of a list.
Okay.
So like it's basically, when we think of foldRight, we're just thinking of constructor replacement. We're just thinking for the list we have 2 constructors: the nil, which is the empty list, or cons, which takes an element and a list and kind of whacks it on the top.
Yeah.
And so here, when we say constructor replacement, we're just saying, well, I can replace the cons constructor with some binary function, and I can replace the nil constructor with a value. And I can kind of play this game to implement a bunch of functions. And one of those functions was, I think we did it for sum. So for sum, you could have said, the recursive way would have been like, well, we have a list of ints and we return an int. So it's like, all right, we have a list of ints. So let's grab the head and tail of that list. And then we can say, all right, well, it's x plus, and we need to basically pass it by the sum of the rest of the list. So you could say sum of the rest, essentially. So that would be the recursive definition, but just as valid as to say, all right, foldRight, I'm going to, first argument will replace the constructor, which is plus, and 0 here will replace nil, the empty constructor. And so we would take something like 1, 2, nil. If we replace those things, we'd see 1, 2, 0, giving us 3.
Yeah. All right.
So that's kind of, that was basically the whole thing. We did some recursively, and then instead of doing it recursively, we went and said, okay, let's do it using foldRight. And one of the nice things about foldRight is that you don't need to have to do this work of like looking in and seeing what the list is and pulling the first thing out of the list. And then, because actually to do this properly, you'd have to say, well, there's actually another case, right? There's a case where the list was constructed with the empty, or in our case, the empty list. And so in that case, we should just return 0. So you've got to handle the base case, you've got to handle the other case, and then you got to work out what the recursive call is. So foldRight's a basic way to abstract over kind of that machinery.
Cool. Yeah, makes sense.
So we did length. same idea, right? foldRight says, hey, I just need 2 arguments. First argument has to be a binary function, right? It needs to take 2 arguments and return some value. And I need the initial, the default value in case it's an empty list. And so for length, you can think about implementing length as saying, well, I just want to add 1. Like if I have a list that's like that list again, like 2, 1, 0. If I can change cons to plus and replace 2 with 1 and 0 with 0, then that would be the length of the list.
Okay.
So you can we're kind of doing this. We're just basically saying, okay, cool. Binary function takes two arguments, and I'm just going to add 1 to this kind of like, accumulator that's like running across the list.
Mm.
So this is where this is where we were now for map. How do we implement map with foldRight? So if I fix that up, and you got to run.
I have to go. Sorry, guys.
But you got it all. That was quick.
Put that recording up. I look forward to watching the rest of it. Yeah.
Actually, I've still got to chuck up last week, so I'll do that today as well.
Yeah, we still got to do last week. I don't know if or maybe we just wait. I don't know how to necessarily do that, but maybe Vito can do it on Monday.
Do the what's that?
Put the other, or can you do it all?
No, I can do it. Yeah, I can chuck it up. That's fine.
Sorry, boys. I'll see you
later. Enjoy your weekend.
Thank you. You too.
Okay, see you, man.
See ya. And then there was 2.
Yes, and then there was 2. A binary audience.
Me in that murderer in the car. Well, all right. Here we go. You ready for a bit of implementing map in a car? This session should be called Haskell in a car. We should do a little series where, like what is it Seinfeld that does the conversations in the car, or comedians in a car?
Oh yeah, coders in car doing Haskell.
Yeah, two lambdas in a
coders in cars. Coders in cars doing currying.
The currying car.
Curry in a car.
Curry in a car.
Hurry?
Curry in a hurry. Or about map in a hurry.
All
right, so we're pretty comfortable with the idea of like mapping some function over a list.
Yeah, so this is just for my to remind me of how the core structure works. That line 176, that's just showing this is how they expect this function to work. When you finish the function, if you give it a function plus 10 and a list, it'll return a list of 1, 2, 3, and 0, or whatever, using our list constructors that we did before. Then we should get back a list of 11, 12, 13. That's easy. They're just describing what they want you to implement.
Exactly. It's like that's like the spec, if you like.
Okay, and then below that, those are kind of like little unit tests. Is that right? Or
yeah, so they're like describing properties about the
gotcha.
So there's actually a tool. There's actually a tool. There's this type of testing called property-based testing. The idea is that you want to be able to say something's true for any x. So here you might say mapping plus 1 over infinity, taking head or x, or mapping plus 1 over infinity gives me 1. So it doesn't matter what x you give me. If I map plus 1 over infinity, I always get 1 back. Or if I take the head of that list.
Gotcha.
So yeah, that's a good point. Yeah, exactly. That's kind of like what do we want to do, and then we have to kind of like go and.
This is the exercise. Okay, I gotcha.
So, and I think I've changed this. So instead of when you print out a list, instead of it printing in like the Haskell type list, I think it respects how we've defined it.
Oh, I see.
So I think when we print out a list in the REPL, I think it does this as opposed to that. That's just a little change that I made.
Okay, I see.
All right, how are you feeling? Are you feeling good about the map?
Yes, I do think so. And there's a goal to use foldRight to implement a map.
Yeah, so we could theoretically we could implement this using recursion.
Mm-hmm.
But I think it's kind of like, you can always do it with recursion, but I think it's kind of like if foldRight can do it, it's kind of like nice to delegate the work of recursion to it.
Yep, I gotcha.
And
is that the challenge? Like, in order to pass the course, I know the course is sort of self-directed, but do they expect you to use foldRight, or like at this point in the course you just have to?
I don't think it would matter if you. Okay. But the other people that I've seen do this online have tried to use. They've like done the same kind of thing as us. They've basically at the start they've gone like, all right, let's try and let's just how we do this without knowing about foldRight, and then come back. Do a first few, then come back and redo them with foldRight, and then like use that for the rest of the module.
Yeah, cool. Okay.
All right. So, old mappy map. We've got some function here. It's +10. And we're going to map it over the list 1, 2, 3. So we always look at the type signature and say, okay, well, the first argument is some function that takes an A to a B.
Yeah.
Then I get a list of A and I have to return a list of B.
Yeah.
So if we think, all right, actually what I kind of like to do is imagine we have that simple list of 1, 2, even say 1, 2, 3, right?
Yeah.
What would we have to choose for the cons, and what we have to choose for nil? Like what do we want to replace that with in order to implement map? So let's say we had some function. That won't give it away. No, that won't give it away.
Well, we'd have to replace. We wouldn't replace cons. But can you replace the value of x like the? No, you can't.
Well, this is this is a good point, right? Because we actually have two things. We have this like function, and then we have like this list.
Yeah.
So you can kind of use two things here. You could like use that function to like stick it in somewhere, or you could use the function on, because we get to look at each element. So you could choose to, instead of having one, like here we have kind of 3 degrees of freedom. We could replace cons, we could replace nil, and we can also use, apply this function to each element in the list.
Okay.
Because we know that this function, this list has a type of list of A. Well, yeah, in our case.
Yeah.
I gotcha. Well, sorry, in our case, it looks like that, list of A.
Yeah.
So, okay. I got. I had to remember then how this works. Okay, we think about map. What do we want to? What's the kind of goal of map? The
goal of map is to iterate over the list, apply the function to every item in the list, and return a new list of the computed values of that.
Okay, perfect. Yeah. That couldn't say any better. So how do we like we kind of get okay, that's what it means to map over a list, but how do we say that? What's how do we say that in Haskell? I guess is what I'm trying to say, right? So you said, well, we want to apply F to every element in the list, right?
Yes.
So we could just apply F to 1, apply F to 2, and apply F to 3.
Yeah.
We won't apply F to nil.
No. Although I guess we could, right?
Well, we can't, right? Because nil is of type list of A.
Yeah, gotcha.
And F only takes an A. It's like, hang on, don't you dare give me some higher order list. I don't want to deal with your listness. So maybe make it more obvious. We could wrap this and little parentheses. So this is, I mean, if someone came to you with a list 1, 2, 3 exactly, you could say, okay, cool. I'll just reconstruct it by calling f on 1, f on 2, and f on 3, and consing that with nil.
Yes.
Now, it's almost like a trick question here, because like, what do we replace cons and nil with?
Can you carry cons with the function?
I mean, you could, but these will evaluate to values, right? These will be B's.
Yeah.
These will be of type B's.
So I think I'm getting caught up because I'm assuming. So I might got a bit vague on that like description 2 lines above, but does foldRight only accept a replacement for cons and a replacement for the initial value? Like it doesn't accept anything else, right?
No, and so in that case, yeah, okay, yeah, no, exactly, that's it. That's your interface. That's all you get is like a function.
Okay.
Sorry, a binary function and
you have to do it with.
Only with those 2 things.
Do it by replacing cons and replacing initial value. That's all you can do.
Yeah, exactly.
Okay. All right, Jen. All right, carry on. I'm with you.
So, yeah. So for a second there, I thought, oh, you just passing cons and passing nil. You just leave them. They just kind of say, I want the identity. Just do the same thing, right? But we've got to like somehow we want this. We want to go from this to this, but we can't be like we have to somehow get into it such that we can like grab 1 and call f on it, and then grab 2 and call f on it.
Yeah, because that's what I was thinking. Can you go like kind of? And the terminology is going to be wrong, but can you like combine cons with the function so that you go from nil, you like function and cons 3, function and cons 2, function and cons 1 to build up your return list? But I don't know how you would do that. How do you?
I think you've nailed it on the head.
Yeah.
Because I think we can compose f and cons such that it does exactly that.
Yeah, because let's say like if we take the plus 10, right, is our function.
Yeah.
What would we have to do to cons plus 10?
Sorry, I say you mean like
3,
we're gonna map. You're saying like f is we're gonna map plus 10. Well, this is okay. So. Okay, if you got to go here, like, and we're like, what will we do? Like, we got to compose. Like, it's kind of like, it's not quite clear how, like, we kind of fit everything together. One thing we can do is just go, let's just open up as lambda. Let's just take x and y and just, like, think about what the hell we have to do in a second.
Yeah, okay.
But it seems like we want to replace nil with nil. We can leave that as is because we want to return back a list, right?
Yes.
So we kind of
nil
stay in the list.
Nil. Yeah, we've got to have that as our. We need to have it run a constructor to get back a list to cons onto.
Exactly. It's, in this world, it doesn't get to change, which is a little sad. But we've got the x and the y's. So if you think like, okay, x, we're doing a foldRight, so we know x will be of type A, right? It's going to be some element from the list. And then y will be in this case, y will be the rest of the list. Or will it?
Yeah.
No. Let me just run that. What do we get? Chucked a hole in there, and it said, okay, you need to return something that is list of B.
A list of B.
Which makes sense because the whole function has to return a list of B. So you want to hope that on each iteration you'll return something a list of B.
Yes.
And it says, okay, I found some bindings. I've got Y, which is a list of B. X, which is of type A. And that kind of makes sense, right? Because we know cons, right, takes A and a list of B.
Yes.
So when we replace cons, it has to have the same like type. In the sense that, was that true? No, that's not true.
No,
that's for cons, it's true.
It would have to be A in a list of A or B in a list of B, wouldn't it?
Well,
but they could be the same.
Well, yeah. I mean, what's happening here is that it's because foldRight is more general, right? It says you can if I give you a list of A, you can just do with A's, or if you want to map A's to B's, that's fine. That's kind of like that's your discretion. You can like take a look at each element and go, hey, keep it as is, or you could say, you know what, I'm gonna run some function over and get some other type. So because if you look at the type signature for foldRight is I return a list of B's, right? So that mapping function has the chance to change type if it wants. In terms of like, if we go, what's the type for foldRight? foldRight. Oh, wait, yeah. Is that whinging because? Oh, that's probably whinging because of. Oh, what's going on? Come on. If you look at foldRight, see how foldRight says the first function, the first argument of the function, it takes two arguments, an A and a B, and returns a B.
Yes.
So this tells us if this was A to A to A.
Yes.
Then this would have to be an A, and this would have to be an A.
Yeah.
But because this takes this function takes an A to a B, it means as long as the initial, you know that whatever is returned is going to be the same type as that initial value that what you replace nil for.
Yeah.
So if you replace nil with 0, you know that the return this B here, the return value has to be of type int.
Yes.
And you know then that if I give you a list of booleans, right? So if I said something like, if I said foldRight function plus, or let's say like, let's say I give you some function, but then I give you I give you true as the B, but then I give you like 0, 1, 2 as the list, or in our case 0, 1, say nil. Here it's like we've got a list of A being an int, so a list of int, and we've got B's a bool.
Yeah.
So it's like, well, hang on, these two things are different. Well, that's because our F, right, might be, say, greater than 0.
Yes.
Which means it can take something of type int and turn it and map it to something of type bool.
Right,
so
right.
This would give us like false, or it would be like greater than 0. So 0 is not greater than 0, but then 1 is greater than 0. And that would be our list when we apply foldRight over it.
Yeah, gotcha.
So yeah, that's a good point. It's like there's this kind of implicit mapping that can happen. It doesn't have to happen, but it can happen. So we kind of think back to map, for example. Got this x and a y. So we know x. So the what is it? The compiler, was it GHCI, told us, hey, look, I say an x, I say a y. This x, I know it's an A, something of type A, and this y, I know it's something of a list of B. So already you're like, oh shit, I've got an A, I've got something of type A, which is x. I've got something of type list of B. I can't join those two together.
Oh.
Right, I can't, if I try to do x x with y, it would say, well, I mean, this will work only because it will say, oh, okay, that B must have been A. Do you know what I mean? It'll like work backwards and say, oh, you didn't do anything. Okay, well then that B wasn't different to A. Right? Because if we did this, it would say, oh, is it whinging about?
Oh, that's weird. Why?
Is it whinging about this? I'm sure you fold
Did we
left.
change?
No. Was it product? That's good. Sum.
That's weird.
That's good. Oh, is that just a warning saying you didn't use F? Maybe. Let's have a look. No, what's that engine? Okay, let's have a look. Few error. Jesus, it's error galore.
Man.
Where do the errors start? Where do they end?
That's a lot.
foldRight. That looks like it's. Hang on, let me reload.
Okay.
Okay, that is. Here we go. Couldn't match type T with a list of char at 75.
Yep.
Oh, I'm gonna get rid of this. Edit 75. Oh, it's foldRight reduce. Makes you think like if we just. I reckon if you go like, oh no, not some. I have this weird feeling that if we like, this won't fix it. If we just have that. Yeah. So what do we change?
I don't think we changed anything. That's really strange.
I
I don't remember changing anything that is referred to in those errors, but I can't see too well. But
we just had the some. Let's have something to do with foldRight. No, that's all. That's out. Do I have? Let's see what Git says. Git diff. Oh, you can't say this, can you?
no,
Git diff.
that's okay. Don't worry.
No, mate. I need your eyes on the diff.
Yeah.
List of T. No, that looks good. Yeah, that's all. Ah.
You find it?
Okay. Yeah. We
Oh, you diffed it.
I changed.
Oh, when you were hypothetically changing those types.
Yeah.
Oh, yeah. Okay.
So this is A to B returns a B. So where are we? You said we're on doing map. Okay. So we said, what do we say? We said you give me my F, and then I'll call foldRight on. Chuck an X and Y in there, and we said, well, we can just imitate cons by just wrapping that in a function and then say nil, and this will work, right? This will. Oh, come on, you're killing us. At least it's an easy error. So it says couldn't match type A with B.
Okay.
Which what is that really saying? Well,
What's Y?
What's up?
I guess the question is, what is Y? Yeah.
Y. Y is a list of. What was it? Y. I think it was. I mean, we don't. It doesn't give us that context, but Y. We know Y is a list of B. So actually, the type system, I kind of didn't give the type system enough credit. We said explicitly, I have a list of A, I need a list of B. So it says, if you're trying to give me back a list of A, then that's not a list of B, right? It kind of says, the type system says, I'm telling you, I want a list of B back.
Yeah.
And I said, and I gave you a list of A, and all you did was give me back a list of A.
Right, I see. Okay.
You never did, you never got to a B. Like I've given you a function as well. So if you give me an A, I give you a B. So the only way you can give me back a list of B is if you apply the function to each element in the list.
Forgive this simple question as always, but I just want to talk through the lambda that you put there. The reason that's working is that's basically just saying replace cons, which is infixed between the two input parameters. Replace it with cons. That's all you're doing. It's just like replacing cons with cons again.
Basically, yeah, you're replacing cons with something that looks like a wrapper around cons,
which is literally cons.
Yeah, exactly.
Okay.
You just so like
But
there.
and the reason it's upset is because you haven't changed. Yeah, you've said that map will give you a different output to the input, and it turns out you're just giving it back exactly what it gave you, and it's like, hang on, this is meant to be different.
Exactly, like the types. If we said list of A, it would say, it would type check would say, cool, you the output's list of A and the input's list of A, and all you're doing is constructing a list of A and the implementation. Sure. But because we explicitly say no, map is list of A to list of B.
So does it even if they are literally the same type, like let's say, we're just adding 10 to everything.
Yeah.
We're still actually returning a list of A, but it's gone. It's just the fact that you said A and B means that you expect some change, even if the type is the same.
No, that's a really good point, right? Because like,
is that true?
Cool. That's exactly, because what happens is like, how does Haskell know? What the types are, like when the types don't match up. And so when you said something like, I want to say map plus 10 over 1, 2, 3, or 1, 2, 3.
Yeah.
Right. When you want to map over that, how does it know that, well, like that the A's and the B's are the same type?
Yeah.
So what it does is it says, okay, well, it kind of does the way the type system works. Is it says, all right, I've got this function of type this is the type for map. It goes, all right, first thing I'm going to do, because we know function application is left associative, so it first applies this. So then it says, okay, I'm going to apply map to plus 10. So it goes, all right, it kind of like fills in the holes in the type system. It says, all right, well, that means that this A to B is a int to int.
Yes.
So it goes, all right, sweet, that's int to int.
Gotcha. Yeah.
Then it goes, but look, you've just filled in, you just replaced A with int and B with int. So that means that means you might have a list of A and a.
Yeah.
Now, if we did greater than 10,
it would be
say,
bool.
Interesting, you're going into bool. Okay, cool. It means you must have list of int to a list of bool.
I see. Okay.
So like each step of the application, it kind of learns more about, like it kind of constrains more what the types have to be.
Yeah, I see.
Which is, that's a really good point, because like, the only reason, say here, because we never took, here it goes, that could be correct. I mean, if you did the right thing, if you just did like, if you kept in the same type, then it would be correct. But I can't guarantee that, because you never called F, which actually gets me to a B. Even though it might be int to int, I still need you to call F so that you are of the B.
Gotcha.
I can't like hope that you never, go into bool. If you did into bool and we type check this, it would say, well, now we're no good. Can I do? Oh. So, all right, given that, so we're very close. Got this cons business. We're just kind of wrapping around cons, pretending to be cons, but like faking cons.
Yeah.
We're a little bit like you in the car there, just pretending not to rob anything. Just conning everyone
around between in this list.
There's a lot of conning going on over your neck of the woods.
Available when you start learning these new words. Like there's just a lot of good puns available when you start learning all these new programming words.
There's a lot of fun to be had.
Okay, has anyone registered consartist.com?
Yeah, you should change your plates.
Cons artist is available. I should change my plates.
That could be your first book on Haskell.
The cons artist.
The cons artist. So we've got. So we want to do this. We really want to do this thing of we want to do this thing, right? We want to say, well, hey, before you call cons, don't just call cons willy-nilly. We want you to do one more thing before you call cons, which is apply F.
Apply F to X?
Yeah.
Or to Y? No, to
Well,
X.
what type is X?